What we're going to be looking at this morning is a review of Part 91 accidents to kind of give you an idea where our problems are, our main weather threat areas. I'm going to look at thunderstorms, its hazards to kind of review some of that. Making weather-wise decisions, pre-flight weather briefings, utilizing briefing sources more effectively, getting a good update, and weather in the cockpit. Now, we recently just published our 2007 to 2009 accident statistics, and during that period, 3 years, we had close to 5,000 accidents with approximately 1,600 fatalities. Now you think about that. That's almost 1,600 accidents a year, 550 fatalities. That's a lot. If you look at weather accounts for over 20% of those accidents. 1 in 4 accidents, and it's actually close to about 25%, is weather related. Weather is our big area of impact. It's your environment, and you need to understand it, plan accordingly. It is something very significant. Now, in this study, majority of the accidents are Part 91 aircraft involve personal flights with fixed wing aircraft, almost identical to what we're seeing out there on the field today. We have changed to using ICAO definitions or CAS definitions for our accident causes. So you may go through that report. You're not going to see weather spelled out for you directly. They're going to use buzzwords such as loss of control in flight or loss of control on the ground. What do you think may be causing the loss of control? Could be an icing encounter. Could be adverse winds blowing you off the runway and so forth. So it's kind of hidden away in there. Abnormal runway contact, again, winds, wind shear. Control flight in the terrain, low ceilings visibility, boom, scud running right into the ground. Unintended flight into instrument meteorological conditions. Thunderstorms and wind shears, again, all factors to our accidents. If we break those accidents down and look at weather, this is what I've came up with those accidents. And again, we're talking about that same period, over 1,000 accidents, weather-related. Look at the main cause of our accidents, though. Winds, adverse winds. Yeah, scrape a wingtip, cause some structural damage maybe. Majority of the time, people walking away from those accidents. Majority of the time. We start looking at low ceilings visibility. Again, significant impact, about 18 to 20%. Density, altitude, carburetor icing, structural icing, turbulence, thunderstorms, wind shear. These are our main enemies. Now, if we look at it again even more, leading factors, we talked about adverse winds and so forth. Let's look at winds. When we start talking about adverse winds, we're looking at, again, a vast majority of our weather-related accidents. High winds. Do you have personal minimums of when you're going to operate? We have crosswind concerns, tailwind concerns, wind gusts. And this, again, even impacts the major air carrier accidents with all these factors. Wind shifts, as variable winds, even low-level wind shear. If we look at the table here, I have non-fatal accidents with red being our fatal accidents. Again, notice adverse winds, vast majority of our accidents. Very small percentage of that is a fatality-related event. However, we start talking about low ceilings visibility, low ceilings, thunderstorms, icing, mountain obscuration. Almost all of those are going to be fatal. Matter of fact, weather accounts for the highest percentage of fatalities in all our accidents. Weather accidents kill, except maybe the wind. Now, I'm going to show you a video, and I'll run through it twice. I'm going to set the stage up for you. You've got a couple, and you're bringing a next couple with you. We're going to go leave our air park vacation home out in the Sacramento Valley. We're going to go cross country. Everyone's packing up their bags. We're going to get in the airplane. Oh, I know my airplane pretty good. I don't need to do a weight and balance. Oh, we're going cross country. Let's fill the tanks. You just put yourself 400 to 500 pounds over gross weight. We got a high density altitude, 4,500 feet. Short field, over a 50-foot obstacle. and we're taking off with a quartering tailwind. Here's the end result. This actually was taken by accident because a film crew was right there and filming it. Weather doesn't always come out and jump at you like a thunderstorm and so forth, but just subtle little things, not doing a good pre-flight planning, tailwind, quartering tailwind, high density altitude, the link of the events are there, and in this case, we have 2 fatalities and 2 serious injuries. What was going to be a nice weekend getaway turned into tragedy. Now, I said adverse winds usually don't kill people, but when you hit a boulder like this, it stops you pretty quick. And again, a very significant accident, and this is in our accident statistics during that period. Weather kills. So before you go, I want to make sure everyone gets a good pre-flight weather briefing. Plan accordingly. I know you know your airplane, but you put those bags on, you need to start thinking about weight and balance. How much fuel do we really need for this leg and so forth. Keep within weight and so forth. Bad news for you, in the majority of those accidents I showed you, about 41% of those accidents, the pilots never received a briefing or got an inadequate briefing. One quick way we can prevent these accidents is get a pre-flight weather briefing. Now that's significant. Now we have a requirement for a briefing, of course, and so often we hear something like this. Well, I looked at the destination forecast and indicated VFR conditions. What about the en route conditions? What do you have to look at for an en route forecast? When was the forecast issued? Are you going to trust a forecast that was issued at midnight last night for this morning? I want an update. Any adverse weather predicted, any thunderstorms, fog, so forth, icing. What's in the surrounding area? What's downstream that's going to move into the area? You need to get the big picture. You can only do that by getting a good weather briefing. What I don't want to see is like something like this on a cockpit voice recorder. Say, what's the mountain goat doing up here in the cloud bank? And boom, we have an impact. So, big impact VFR and IMC conditions. I think you'll agree. Is fog violent? Does fog reach up out of the clouds and grab the tail of the airplane, shake it, and spit it out? Nah. Nice and subtle. Not a violent dynamic, but again, it's our #1 cause of fatalities in Part 91 accidents, the VFR and IMC conditions. #1 cause of ATC delays, costing billions of dollars to the U.S. economy. Common factor in runway incursion incidents and accidents for the major airlines. Common factor in all the controlled flight in the terrain type accidents. And again, flight crews not adhering to standard instrument approach procedures. Now, here we look at this one. A quick question for you. What would you say was the worst aviation accident in history so far? Tenerife. I don't know if everyone remembers, but we have a fog-shrouded Canary Island. We have KLM 747 taking off, rushing, trying to get airborne. We worry about duty time, so forth. Pan Am still taxiing on the active, and we have a runway incursion with 583 fatalities. Worst aviation accident in history, fog setting the stage. Not the only single cause of the accident. Again, it doesn't reach up and grab the airplane, but is very unforgiving to any errors. Fog is a contributing factor. So VFR and IMC conditions is something significant. It is a major impact. A good weather briefing is our starting point. Now, I'll give you an example and throw some accidents in here. Here's a case that happened here in Florida with an RV-7 up in Sanderson, Florida back in July 2009. And here we have this beautiful RV-7 and non-instrument rated pilot. He's going to go across country to pick up his girlfriend and fly her back to Sun City to let her see the property down here. He calls up there and finds out the weather and so forth, but he calls up her, hey, what are the conditions up there? I'm going to fly up, I'll pick you up and so forth. Never gets a formal weather briefing. Departure and the destination are VFR. But again, what about the en route phase? Here's an example of what he would have gotten if he looked at a weather briefing, or specifically even on the internet and so forth. We have a stationary front right across Georgia into Alabama, Mississippi there. But look at that little trough coming down, and look at that band of convective activity riding ahead of that front and the warm, moist air going over. And do you think you can clearly make that VFR? In this case, he encounters an area of embedded thunderstorms trying to get to Tennessee and never gets out of the state. Yeah, the Tampa area where he departed, VFR. Northern Georgia, there's the current conditions closest to the accident site. 2.5 miles, thunderstorm and moderate rain, ceiling at 1,000 feet, overcast at 2, lightning and so forth in the area. And again, witnesses report low overcast ceilings, rain, thunder. Not good. Here's his flight track over the radar. You can see his trip going north. He comes into the weather, has to deviate. He's got Gainesville right there. He could have made a stop, landed, taken a coffee break, gone out for a little breakfast, whatever, let the storms pass by and maybe reevaluate the conditions. Instead, what does he do? Continue to push a bad situation. And he eventually turns into the weather, and we result in an in-flight breakup, and the remains are right here. Took him 3 days to find out he had crashed. If he had lived and was injured, it would have been 3 days before anyone even came looking for him. His girlfriend thought, well, he must have encountered weather. He diverted. Oh, he'll be here later and so forth. 3 days before they found the wreckage, and again, no survivors. There is a requirement, 91.103, pre-flight action. Anytime you're not operating not in the vicinity of the airport, you familiarize yourself with all available information, reports, forecasts, and so forth, weight and balance, and so forth. The key words here is safety. It's better to think about it down here than to worry about it up there. And again, to make good decisions. Now, there are multiple ways we can get a weather briefing. We have the Automated Flight Service Station operated by Lockheed Martin. We've got Direct Users Access Terminal Service, DUATS. We've got the internet, private vendors. One word of warning, there are only 2 official recognized sources for briefings, and that is through Flight Service Station or with DUATS. And I'm going to recommend that you use them, but hey, how many people here have laptop computers or a computer that they use? Oh, I want to see hands going up because you need to get the big picture. Highly recommend to grab one. In a standard briefing, we're going to talk about the adverse weather, synopsis of what's going on, current conditions, en route forecast, destination, alternate planning. If you can't complete the flight, what are you going to do? Winds aloft, notice to the airmen.
Ever heard of a little thing called the internet?
Computers, amazing devices.
Press any key. Where's the any key?
You notice that's how I started this, trying to find that any key. But basically, I highly recommend using the computer, the internet, get an idea of the large-scale picture. Now, I will always recommend the National Weather Service website, first and foremost. They are the official source. Those are the people you want to use. If you go to the ad site or the National Weather Service site, you'll see this right offhand, and you get a quick bird's-eye picture of where IFR conditions are, marginal VFR, icing, turbulence, color-coded, right in the opening page of the chart. It is the official National Weather Service site. You can get domestic as well as international products.
Welcome to the internet, my friend. How can I help you?
And all the National Weather Service text and graphics right there. So use their page. And I want to kind of also warn you right here, even the National Weather Service page has a warning that it is not an official source. Use it, but you supplement it by calling Flight Service Station or get a DUATS. So you got the picture and you get a confirmation. And as well as you now have it on record that you got a weather briefing. Clean up liability issues and so forth. How many people have ever used this reference book? Advisory Circular AC 0045. Aviation Weather Service. Matter of fact, you can even get it on the internet and download it. Highly recommend it. But again, Gleam, Sporties have it. Great reference manual. And I'm going to throw one thing to you. It has how to read every product that you're going to see on the National Weather Service page. And it's also listed as required knowledge for every airman certificate, i.e., is it a regulatory book? It sure is, because you have to know what's in that book. Now, give you another example. We're going to go to the surface analysis chart. I want to see what the large-scale picture is, and here I pull one up. This happened to be from March 31st, 2011. I get a quick idea of the isobars, lines of equal pressure, which helps me give me wind direction. I've got a frontal system here, and notice it's stationary, a little bit of a wave on it, and a well-defined cold front coming down. You notice it's not straight, it's curving, it's telling me there's circulation, there's interaction, there's vertical motion implied. Fronts have the area where we're going to see clouds, moisture, and again, convective activity and things. Matter of fact, what's this line with two dots there? Does anyone recognize that? Say again? Say, not a trough, squall line. What is a squall line? An active line of strong to severe thunderstorms. Do you think that's important information to know? Heck yeah. Matter of fact, it scares me sometimes when I even teach this to air carrier pilots and they don't recognize the symbol. Are they even looking at a map? So squall lines are very significant. That's from a year ago, yesterday. What happened in Southern Fun last year? Severe thunderstorm goes through, winds of 65 knots, over 40 aircraft damaged or destroyed. There's some of the impacts from it. And again, beautiful aircraft just with a passing storm coming through around 2 o'clock in the afternoon. And if you notice, a lot of this is right out here between Piper and Cessna. You'll see even the hangars in the background, all from a severe thunderstorm that raced through the area. Now, using the National Weather Service website, you can pull up the radar. You can click at any specific station, and you can even get an animation. This is the radar animation from last year showing the severe weather. And you notice there's a little bit of a line, and you'll see the intense area of echoes going right across our area, even a little bit of purple. When you see that purple, that's hail. When you start talking about reflectivities over 65 dBz or decibels, significant. But that's a line of an embedded heavy precipitation supercell. And if these terms aren't familiar, those are severe weather signatures that we try to kind of exploit a little bit. There was a tornado watch issued 6 hours prior to the event that happened here. And they talked about a ongoing quasi-linear complex of strong to severe thunderstorms included embedded supercells and bow echoes. To me, as a meteorologist, that sings, oh, there's action. But that's talking about a squall line. Embedded supercells are the severe tornadic type conditions. A bow echo, those are what Fujita identified as one of the #1 causes of tornadoes, as well as from the supercell. And again, what comes through the area around 2 o'clock in the afternoon is we get an F1 to F2 tornado going across the field. So, using the National Weather Service webpage again to continue with our briefing, we can look at the trends, looking at the 12, 24, 36, 48-hour prog, get an idea, hey, how are conditions expected to change? These are the same maps. If you go out to the Lockheed Flight Service Station right here, they got posted. I start my day every day looking at the trends, how things are going on. The Weather Channel will use the same products. And here we've got the frontal systems. They kind of tell you the area in green there of where we're looking at expected precipitation. Where they shade the area, it's greater than 50% of the area, i.e. you're going to get that precipitation. Now, if you were going to leave Lakeland going to, let's say, St. Louis, is this a good day to fly? Well, you may get a good tailwind, yeah. But how many people have airborne weather radar and that capability? If you don't, I would say it's a better day to sit back and enjoy an air show or make alternate plans. I wouldn't even attempt to go that route, or I'd maybe go up the East Coast and then cut over. I know longer distance, but again, you have to make plans. I helped run TWA for 14 years. We reroute due to weather. We cancel due to weather. Weather determines route altitude of flights. We don't have confidence in the expected conditions. If we can avoid it, I'll take a different route. Otherwise, we have to do things. And of course, I'm talking about an airplane that can go to 40,000 feet and top most of that activity. I don't think there's too many people in here that their aircraft can go to 40,000 feet. Oh, okay, I got one here. Okay, lucky you. But again, we're going to look at the fronts, the pressure systems. I look at the pressure tendency. Is it getting stronger or weaker? How's it wrapping up and so forth? So we're going to look at that. The wind flow, again, precip type coverage. I like to look at the satellite imagery. If you were at our booth yesterday, we were watching a satellite, the radar, as this activity developed. Look at satellite, bird's eye picture of the activity, and look at your size of thunderstorms. Your areas of fog will show up on satellite. We use satellite in almost every investigation we use because it gives you the bird's eye picture. We have the adverse weather, and if I go into convection, I've got 4 major tools to use for convection, looking at the convective segments, the collaborative convective forecast product, Center Weather Service, meteorological impact statements, as well as the convective outlook. Here's the convective segments. I got it graphically. Where are they talking about? Word of warning. That's current conditions, the forecast positions you're supposed to translate with the wind flow. So if I'm, as example, going towards Kansas City, guess what? Next couple of hours, that's likely going to be in Kansas City. The convective outlook chart. This is where the National Weather Service will categorize thunderstorm potential. They'll say a general air mass thunderstorm to the right of that gold line, but in that green where they say slight chance, red line, moderate or purple, high potential of severe storms, tornadoes, microbursts, strong winds, storms that are going to kill you. I look at this in any bullseye area, I'm going to make sure I'm going to get updates almost hourly to find out what's happening, how things are changing, because again, they are talking about the Severe Storms Forecast Center giving you information of where the most nastiest convection is going to be. We've got the regular air mets. Here's an example of the convective segment during the period. We can also get our graphic air mets to see the areas of impacts. And again, depending on your limitations, be it IFR, surface winds and so forth, you can categorize which specific warning, but get the bird's eye picture of what's going on. One final thought on pre-flight weather planning. I know you may disagree with this, but weather forecasts are not always perfect. It's an educated guess. Weather conditions change. There's a front in the vicinity, convection expected, early morning, evening departure, fog concerns, low ceilings. Get an update. We have a whole system in place with Flight Watch, hazardous in-flight weather advisory services, and other weather broadcasts to transmit this information. Get an update, get it regularly. National Weather Service products are updated on a regular basis. TAFs are issued every 6 hours. Convective segments every hour at 55 minutes past the air mets every 6 hours, as well as amendments. Segments, weather watches are unscheduled, but when conditions are expected, the advisories will come out. Pilot reports are constantly coming in, telling us confirmation what's going on and what's out there. The hazardous in-flight weather advisory service, if you're going on your sectional chart, the little H in the circle does not mean heliport. It means you have weather information. HIWAS, if you're using the low altitude chart, the same little symbol in the corner tells you by turning into that frequency, I will get a continuous broadcast of any adverse weather product being issued, as well as any significant pilot reports. En route flight advisory service or Flight Watch, again, available from 6 until 10 o'clock at night on 122.0 below 18,000 feet. Again, talking to an individual can help you say, hey, what's going on out there? Give me the scoop of how these things are changing and so forth. and get a better idea of what's occurring on the impact. A lot of people are starting to put weather in the cockpit. It's a great tool to help increase your situational awareness. I will caution you one thing, like as an example in that right image there, and here we're looking at our route and so forth. Do you see any potential problems? That route is not safe. And that picture you're looking at is not current. It's going to be a minimum of 6 minutes old, realistically 10 minutes old. It's history. That's 10 minutes old. I want everyone, when you start looking at any palm pocket, any cockpit weather, I want you to put that in your back of your mind. It's 10 minutes old. It's history. That's what it was 10 minutes ago. Where is it moving? Is it developing stronger? Spatial resolution of data. If you're looking at the charts to give you an idea where marginal VFR and IFR are, it only works good with reporting stations. If I don't have any reporting stations, you're not going to get any information. And also with radar, when you start talking about west of the Rockies, radar coverage goes down and you don't have adequate coverage. There are still gaps in the United States where there is not good radar coverage. You will not get clear indications. That is old information. Look at the top left picture. Is there any problem with that flight? Oh, we're going to avoid the severest part of the weather. He's still penetrating an area of thunderstorms. Matter of fact, what is a thunderstorm? Where does it start and where does it end? You see the light green area? That's the precip beginning of the thunderstorm. The cloud goes further. You can get turbulence, hazardous weather within 20 miles of that cloud. It's not the total picture. Even looking at a Palm iPad type thing, again, 10 minutes old. And would you use that to go flight to in this case, down towards West Palm Beach in this case? Or are you going to have a smooth flight? You're going to be picking your way across and still have some potential problems. You need to make good, sound decisions. It is old information. If you can visually see it, you're better off. But again, embedded storms and so forth, we've got limitations. Now, don't push a bad situation. Conditions worse than expected, make an alternate plan. Do not penetrate into an area of bad weather. Make a command decision, divert, alter your plan, turn back, wait it out, take a break, consider the frontal position, its movement, prevailing winds, convection, time of day, and so forth. But again, don't push a bad situation. Thunderstorms. One of the big questions I have is people who always ask me, what's the worst? Why is it so much dangerous? All your hazards are put in one thing with the thunderstorm. And in Florida, I'd say that's probably one of our biggest threats in the whole Southeast, actually, but again, anywhere in the country. Now, there is a great advisory circular out, which is going to be updated as a result of several recent thunderstorm accidents we've had. This was actually written after, remember Southern Airways in New Hope, Georgia? I heard someone said they were from Rome, Georgia here, close to your neck of the woods. We had a DC-9 penetrate an area of severe thunderstorms, flamed out engines, crashed and burned, and this advisory circular was issued back in the 70s to provide you warning on thunderstorms. Great tool, but again, a little out of date. We're going to update it, or the FAA is going to be updating it due to our responses of accidents. They start talking about the hazards of lines, like that squall line I showed you before. I'll throw this to you. Anything organized in a line is bad. 80% of all our severe weather comes from line activity. If someone tells you, hey, we've got a line of convection developing north of us, I perk up. Lines are bad. 80% of the time produce severe weather. Any storm they start talking about as being tornadic, oh, you better perk up. Is a tornado going to show up on weather radar? Remember they talk about that figure 6, the hook echo? The tornado's in the hook, but in an area of no echoes. So again, anyone, you need to be alert. You will not see it. There have been several cases of in-flight breakups due to flights encountering tornadoes. Turbulence. Every thunderstorm is capable of producing severe to extreme turbulence. Severe icing, hail. Every thunderstorm has hail. Only 3 to 5% ever reaches the surface. Remember that. Everyone's got hail. It's very rare for you ever to see it at the ground. If they're reporting hail in an ob, you know it's bad, and it's going to be big because it's melted before it's got down there. Low ceilings and visibilities, altimeter errors, lightning. An average thunderstorm will produce 200 lightning strikes with, again, how much? About a million volts, 100,000 amps. Fry your radios and all your avionics real quick. Every thunderstorm has capability of producing heavy rains, variable winds, runway contamination. I've got that in a different color because that's not in the advisory circular right now. Engine water ingestion. Engines burning fuel-air mixture don't work good with fuel and water. Air gets cut off, boom, engines fail. As we also look at wind shear microbursts, and again, microbursts were not even well recognized back when it was written, but again, a major concerns, as well as radar attenuation. This also is in that advisory circular. It's a cross-section of a thunderstorm showing, again, the intense leading edge. Now, I want you to kind of think of that little lip that's coming down ahead of that. That's where we're going to see our worst updraft, downdrift interaction, our severest weather. But look at the weather underneath that storm, pushing out ahead of that thunderstorm. That's our gust front. Typically, gust fronts can extend forward 5, 10 miles. I've seen them up to 30 miles away from storms bringing down airplanes. And to give you an idea of, and again, these can go several thousand feet high. We had one go through yesterday, luckily not while we're doing any air shows, but here's an example of some research that was done. There's a severe thunderstorm up on the top part of this image. You notice all the cumulus, well-defined cumulus cloud going up. This storm is pushing up to around 45,000 feet. Look at the anvil to the left, and look how thick it is. A thick anvil. That thing is, if you look at the main cloud, that's 20 miles. That's going down 20, 40, 60 miles downstream. On the bottom is the radar image to it. And you'll notice the intense core of activity associated with the main cell, some very significant turbulence at altitude. But if you look near the surface, you see these several surges coming out. If you look out about 20, 30 miles, there's a well-defined gust front there, and there's actually another surge right underneath the leading edge. What does that look like? Well, I'll show you an example of what it looks like. This is computer modeling of what a gust front, a strong gust front, can do. Now, you think if you're a light aircraft operating in that, as an example, it actually doesn't have to be a light aircraft. I could put a 737 into it. It'll flip it and turn it and put it in the ground just as quick. But that is what happens when we mix that cold, dry and moist air together, cold and warm. We get these turbulent eddies, and we can lose airplanes pretty quick. They do occur. Now, remember that little lip that you see in that leading edge? You may see something like this, a shelf cloud or actually even a roll cloud along the leading edge. And I hate to say, I've had accidents where the passengers have taken their iPhones and taken a picture, and we see this, and hurry, we got to get it in here and get out and beat the weather. And guess what? They don't beat it. When you see this, you better stand by because you're going to get a surge of cold, strong winds, and boom, we get the front go through. Give you an example. This happened in, again, our study period in Doherty, Texas, in 172. Again, a sad story, a cross-country flight. Husband and wife, no weather briefing, no flight plan followed. Witnesses report blowing dust, high gusting winds at the time of the accident. Here we have a loss of control in flight after encountering a gust front. And again, here's the observation from Lubbock. Winds 260 at 37, gusting to 51, 3/4 of a mile, blowing dust. Base of the clouds, 3,000 scattered, ceiling at 7,000. High base thunderstorm, but that means high cold air coming down, surging out, and this is what we have as the end result. Here's our route of the cross-country flight into Lubbock, and on the surface map, we have a little brown line there, and they're saying an outflow boundary. Outflow boundary is another word for gust front. And here, This is what it looks like on weather radar. That little blue line, the white dot is where the accident is going to occur. That little light blue line is the gust front, a very light, very thin echo. And in this case, it's moving right across that area, right as the aircraft encounters it, and that's what it looks like. Weather-related accidents, you're typically not walking away from. In this case, it took them 3 days again before they even knew that that's what it was out in the middle of the field. And that's all that's left to this 172. Every thunderstorm implies severe turbulence. National Weather Service typically goes with 16 levels of reflectivity. We used to go with the VIP scales 1 through 6. They're not used all that often anymore. However, they're still there in reference. Any storm over 40 dBz is going to produce severe turbulence. And again, we have rainfall rates and so forth. Now, this chart I'm going to throw to you real quick. I want to kind of highlight a couple of things. The 3 bar colors on the far right are how the National Weather Service, initially when they put the radars in, they sold the rights to distribute the radar, the 3 major vendors, Unisys, DTN, and WSI. When you get weather in the cockpit, they're going to use one of these scales. And what they do is basically, here's that 16 levels, and give you the idea of what you're seeing. Now, when you look at the middle, we have what airborne weather radar, and if you have weather in the cockpit, they will use that same scale to match airborne radar. I want you to look at that weather scale to the far right. When you look at that weather from the Weather Channel or on the ground on your internet, notice the scales do not match up. If you're on the ground and you start seeing that dark green to yellow to getting into the little orange, we're talking thunderstorms. But notice if you look at your cockpit display, that's already red. Where I see red is real intense activity, the stuff that's going to really kill you. You are not going to clearly see that with airborne weather radar or weather in the cockpit, unless you got an iPad, which again are not the recognized sources yet. But again, there's a different scale. Airborne weather radar starts at 20 dBz to 30, 30 to 40 for level 2, 40 and above. Attenuation, scattering, absorption of radar energy is applied thereafter. ATC will use those 16 levels or 6 National Weather Service scale to 4 levels now. ATC will report light 10 to 30 dBz, moderate 30 to 40, heavy from 40 to 50, extreme above 50. ATC will say precipitation. They will not tell you thunderstorms. Now, we have taken, since the Southern Airways accident, about 25 years to get it in ATC in the centers. They have what is called warp now. Again, using those 4 scales, and notice they're using a total different color scale, but again, an indication of how to use this data. We do have an excellent safety alert bulletin that's issued by the NTSB after many thunderstorm encounters, including our Scott Crossfield accident. I highly recommend going to the NTSB webpage. I believe we're almost out of bulletins on this subject, but we also have good ones on icing, controlled flight in the train, and so forth. But again, you need to know how ATC is going to help you provide this information. Matter of fact, what's ATC's primary role? Separate known traffic. Where does weather come into that? Only if you start asking, hey, what's it look ahead? You need to know how they're going to communicate, how to use that asset, if you will, because you do have limitations unless you've got airborne weather radar capability to go 40,000 feet. If you don't have that, you need to use your resources effectively. Now, I'll give you another example. Here's a flight where we are talking about professional pilot flying in a 135 operation. Here we have a Golden Eagle, 25,000 foot ceiling capability. Okay, he can climb over some of the lower stuff. Equipped with airborne weather radar. He's got storm scope for lightning as well as XM satellite mounted in the cockpit. He gets the weather briefing. And again, multiple briefings. Loads up with his 6 passengers. He tells the briefer they anticipate that they're going to have to deviate around weather. But again, the briefer says, hey, this guy's instrument qualified. He's got radar. He's got good equipment on the airplane. Hey, he's legal to go. Here's what the weather scenario, if he had gotten a graphic image from the internet on his laptop, he would have seen a low pressure system, a trough of low pressure. Look at all that convective activity ahead of that trough. He's going from Texas to Tampa. Does he have a problem? Here's what the radar image looks like, and here's his black flight track coming in. And again, now he's forced to penetrate. If you have airborne weather radar, by the way, the moment you start getting into that cloud and into precipitation, you can have about a 10 dBz drop in reflectivity on your radar. That's one full level. So what was level 30, 40 dBz out there is now going to be painted differently. A lot of people don't know that. Radar's for avoidance. Penetration, all bets are off. Here he comes penetrating it. He gets into, notice, just into the yellow, into the bright yellow on my radar. It's right on his display. He starts reporting severe turbulence. ATC yells at him because he's down 4,000 feet from his assigned altitude. Then ATC realizes this guy's having a problem. He says, hey, we're getting severe turbulence. I'm sorry, I can't maintain altitude. I'm trying to climb back up. I'm full power trying to climb. It's not allowing me. ATC gives him his altitude and says, hey, would you like to turn around? Yes, I want to get out of here as quick as possible. And he does start to make the turn, but what does he turn into? The severest part of the storm. And he's got XM radio, he's got storm scope, he's got airborne radar, and that thunderstorm still is going to take him, grabs him by the tail, shakes him, and spits him out, and we still haven't found the airplane. We found the floating debris, and 6 fatalities with a professional flight crew making a bad decision about penetrating an area of weather. So, signposts are there in the sky. Just like this, stop, make a good decision, get an update. Hey, just because you have airborne radar doesn't mean you're safe to go. You know, we used to deviate, cancel, and so forth. And again, once you start operating into that convective segment area, it's known area weather, it's your decision to penetrate that weather, and that responsibility is on your shoulder. That's basically all I have to tell you, and I say keep it safe, get a briefing, and remember, weather kills.